All right, y'all, hello and welcome to your final video of this semester. Yay, we are so excited about that. We don't have to listen to Miss Avra's voice for a whole 3 weeks. Everybody wins. Okay, today we are starting with graphing quadratics to solve for two things, to convert from standard to vertex form and to find our solutions or x-intercepts by using our calculator. Okay, so it says, given the equation below, find the following attributes of the quadratic function. Standard to vertex form, just like it says, vertex form, we need to identify the vertex. Our vertex is at the point HK, where H represents the x value of the vertex, K represents the y value of the vertex. So what I always do first is I graph the function. So if you're in your calculator, go to New Graphs, and then type in the equation exactly as you see it. I've got 3x squared plus 6x minus 1. Press enter, and then the function should appear on your screen. Okay? To find standard to vertex form, like I said, the first thing you do is graph the function in your calculator, just like this. The second thing is to identify the vertex. You can identify the vertex by going menu. Oh, you can't see that, can you? Menu. And then scroll down to Analyze Graph. And then we need to pick between a minimum or a maximum. If we're looking at this function here that's shaped like a U, or an upwards facing U, we know that our vertex is a minimum. So to identify the vertex, we do Menu, Analyze Graph, and then we pick a maximum or minimum. In this case, we're picking minimum. So Menu, scroll all the way down to Analyze Graph. We're finding a minimum in this case. And then you should see this dotted black line. Scroll to the left of your function first and press the center button. Then scroll to the right of your function. Keep scrolling, and then press the middle button. And we should get that our vertex is at the point -1, -4. Okay? Now what I always do is I sketch the function at this point. I know my vertex is at -1, -1, 2, 3, 4. From there, I just do a rough sketch based on what I see here. So I see it goes about like that, about like that. Okay? So I label my vertex first. My vertex is at the point -1, -4. Reminder that that is my H value and my K value. From there, I just plug into vertex form. So the last thing that I do is plug into vertex form. Don't forget that we have an A value as well. So we have our H and K value, which goes into this part of vertex form. But we have this A value in front. Reminder that your A value is whatever number's in front of x squared. So I know H is equal to -1, I know K is equal to -4, and I know A is equal to 3, and I just plug it into vertex form, which I see here. So I've got y equals ax minus h squared plus k, and I plug in for vertex form. Y equals my A value of 3, parentheses x minus my H value of -1, squared, plus my K value of -4. I'm going to write this right up here where y'all can see it. Your final answer should be y equals 3x, that -1 becomes a +1 squared minus 4. That is your final answer for vertex form. Okay, the other thing we can do on our calculator is find solutions or x-intercepts. After we've graphed the function, we want to identify those x-intercepts where the function touches or crosses the x-axis. Oftentimes on your test, you will see the question written like this: f of x is equal to 0. If you see find where f of x is equal to 0, it means find the x-intercepts. Okay, so again, I can do that on my calculator. So I'm going to bring the calculator back over. We again go to, I'm going to use green here. We again go to Menu, Analyze Graph. But this time we're looking for a different piece of information in the graph. So we go to Menu, Analyze Graph, and then we scroll down, or it's actually the first one, a 0, and we press Enter. So I scroll all the way to the left of my function, and then I scroll just to the right of the first 0 on my graph, and I see that it is at negative 2.15. So right here, negative 2.15, comma 0. Okay, that is my first x-intercept. Notice that I have a second x-intercept here as well. So I go Menu, Analyze Graph, 0, and then I repeat this to find the second x-intercept if there is one. Okay, so I do the same thing again. I go to Menu, Analyze Graph, calculate my 0, scroll just to the left of my x-intercept, then scroll just to the right of my x-intercept. And I've got here that it's 0.155, comma 0. So my two x-intercepts are x is equal to negative 2.15 and x is equal to 0.155. Okay, from here, I forgot my pause and practice sticky note. I will make one really quick. From here, yeah, this is improvising at its finest. Here you are going to pause and practice on the next quadratic problems, and you are going to pick back up on day 3, part 2, which is inverse and composite functions. Okay, so moving on. First, we're going to look at inverse. Reminder, our definition of inverse is we switch the x and y values. Switch x and y values. Okay, really important here is the notation. The notation for inverse is f to the negative 1 of x. So whenever you see that notation, it means inverse, f to the negative 1 of x. The other one we have is our composite function. Remember, a composite function is a function within another function. It's putting the functions together. We have a different notation for that. The notation for that is f of g of x. Okay? So these notations look similar because they both have f's in them. But reminder that f to the negative 1 means inverse, which means switch your x and y values. F of g of x with this little circle here means a function within a function. The external assessment loves to put these two questions together and see if you can understand the difference in the notation. So let's look at this first question. It says find f to the negative 1 of x. Anytime I see that, I just cross through that and write inverse of f. That's what it wants me to find. So that means I need to switch my x and y values. And it says of f, so I know that I'm using this function here. So I'm going to do my work right over here. I always change f of x to equal y. So I've got y equals 2x minus 1. From here, I'm going to switch my x and y values. So I always write a blank space where x and y are. So it makes it a little bit easier for me to switch my x and y values. So I've got x and y here. Now I'm switching the places of my x and y values. So here, if we want to write some directions on the side, we switch x and y. And then we solve for y, or get y by itself. So if I'm solving for y here, the first thing I'm going to do is add 1 on both sides. I've got x plus 1 equals 2y. And then I am going to divide by 2 on both sides. So my final answer, which I'll write right over here because these 2's cancel out, is x plus 1 over 2 is equal to y, or if we want to write it in inverse notation, is equal to f to the negative 1 of x. Okay, so that is finding our inverse. Notice our next one again is in this notation. This means find a composite function. So this one is our composite function, given the notation. Okay. I always write inner and outer because it helps me keep them a little more organized. The first one is your outer function. The second one is your inner function. The second one is your inner function. Okay? So if I'm rewriting this, I would rewrite this as f of g of x, where f is my outside function, g is my inside function. Okay, so here again I am using my function f as the outer function, and I leave a space where this x is. That's where my g, or that's where this function, my inner function, then gets plugged into. It gets plugged into the x value of the outer function. So when I write these, I always write 2, and then I leave a big space for where my inner function should go, minus 1. And now I'm going to plug in my inner function in for x. I've got 3x squared plus 2. Okay. Now there's one other piece of notation here that is pretty important, and it's this 1 right here. Okay? Whatever value is in the parentheses next to the composite function, that's what x is equal to. So x is equal to 1. So if we're looking at the function that we've written here so far, I know that x is equal to 1, so I can plug in 1 for x. If I do that, I end up with 2 parentheses 3, 1 squared plus 2 minus 1. And lucky for me, I can pop that entire thing into my calculator exactly as I see it to get my final answer. So if I go to calculate, it's 2 parentheses 3 parentheses 1 squared plus 2 minus 1. Okay, when I pop that into my calculator, I get, oh, there's a bit of a glare there, but I get 9. So this whole thing is equal to 9, so my final answer here is 9. Okay, so be really, really careful on the notation with inverse and composite functions. At this point, we are going to use my makeshift pause and practice. So pause and practice these next 3 problems, and then we will move on to our very last day 3, part 3. And here we are looking at solving for exponential and logarithmic equations. I think these look pretty challenging. The math behind them isn't that hard. It's understanding what the question is asking you. Okay? So this one says Jose takes medicine. After T minutes, the concentration of medicine left in his bloodstream is given by this equation. AT equals 10 times 0.5, 0.014 T, where A is in milligrams per liter. The first one says write down A of 0. Okay, so I've got this equation here that I'm going to write a little bit bigger because I know it's kind of hard to see. It's equal to 10 parentheses 0.5 to the power of 0.014 T. Now this says write down A of 0. Remember when I see something in parentheses like this, it indicates that X, or in this case T is equal to 0. So all I have to do here is plug in 0 wherever I see T. So this becomes A of 0 is equal to 10 times 0.5, 0.014 times 0. I just plug in 0 wherever I see T. And again, I can pop this straight into my calculator. I've got 10 times 0.5 to the power of 0.014 times 0, and I get 10. So I get here A of 0 is equal to 10, and that would be milligrams per liter. So again, the question looks challenging, but it's really just asking you to plug in values into an equation you've already been given. Okay, this one says find the concentration of medicine left in his bloodstream after 50 minutes. So after 50 minutes, Minutes is a unit of time, so here t is equal to 50. So again, I know the value of t, and I'm trying to find the concentration. So all I'm going to do is take 50 and plug it in wherever I see t. So here I'm going to get A of 50 is equal to 10 times 0.5 to the power of 0.014 times 50. And when I do one like this in my calculator, I've already got the equation from before, so I just scroll up, highlight this, and press enter, so I can delete and edit the equation from before. The only thing I need to change here is I need to turn that 0 into a 50. And I get 6.15572. So this is equal to, or A of 50 is equal to 6.15572 milligrams per liter. Okay? Now the very last one gets a little bit trickier because there's a little bit of solving that we have to do. This says at 13 o'clock, which is not a unit of time I ever used, but it exists if you're in the military. When there is no medication in Jose's bloodstream, he takes the first dose of medicine. He can take his medication again when the concentration of the medication, let me do this in a different color, when the concentration of the medication reaches 0.395 milligrams per liter. Then it says, what time will Jose be able to take his medication again? So T, we don't know the value of. That's what we're trying to solve for. Concentration, or A of T, we do know the value of. A of T is equal to 0.395. Okay, so again, we plug in what we know to our original equation here. I know that A of T is equal to 0.395 is equal to 10 times 0.5 to the power of 0.014 t. I don't know the value of, so I'm going to leave it as t. Okay. Now here I am solving for an unknown exponent, and when I'm solving for an unknown exponent, we know that logarithms get involved. So here I'm going to use my reverse order of operations, or SADMEP. I don't see any addition or subtraction, so I'm going to look for division or multiplication. I see multiplication between the 10 and the 0.5, so I'm going to divide by 10 on both sides. Okay, and I'm going to draw over here because I'm running out of room. I do 0.395 divided by 10. That gives me 0.0395 is equal to, these 10s cancel out, and I'm left with 0.5 to the power of 0.014 t. Now here is where I have to get my logarithms involved because I have a base and an unknown exponent, so I need to convert this to logarithmic form. Remember, log form, we need to find the base, the argument, and what it's equal to. Excuse me, I start with the base here, so that goes in my 0.5. I go across the equal sign, that gives me 0.0395. And then I go back around the equal sign, 0.014 t, my circle method. Okay. Very last thing that I need to do, t is not totally by itself yet. It's connected to 0.014 by multiplication, so I need to divide by 0.014 on both sides. Okay. And that is going to leave me with something that I can plug into my calculator. I know that this is hard to see, so I'm going to rewrite it over here. Log base 0.5 of 0.0395 all over 0.014. So I'm going to plug that in my calculator. I set up my fraction bar first, and I've got log base 0.5, 0.0395, all of that over 0.014, and I get 333. So I have t is equal to 333 minutes. Excuse me, sorry. So 333 minutes after 13 o'clock is when he can take his medicine. So 333 minutes after 13 o'clock. And that is my final answer. At this point, this is the last round of my makeshift pause and practice. You're going to pause and practice, finish the last two problems at the bottom, and then you are 100% done with your review packet. Thanks for a wonderful semester of listening to our voices on endless amounts of these videos. One day we will come up with a lovely sign-off. Happy mathing until then.